It's the oldest dream in science fiction, to conquer space, the final frontier. While generations have looked to the heavens and marveled, sci-fi writers and filmmakers have offered us fantastic visions of mankind's exploration and settlement of the cosmos. Until now, only an elite few have known firsthand the wonders of space, but all that's about to change. Scientists predict that interstellar travel, warp drive, and even planetary colonization may someday mean we all get a chance to boldly go where no one has gone before. But have scientists got it right? And if so, are we ready for a life among the stars? It looks like a science fiction fantasy, a fully functioning moon base. But by the middle of the 21st century, such a scene could become a reality. The reason? Water. Millions of tons of water have been discovered at the lunar poles, the frozen dust of comets thinly scattered on the surface soil. Once harvested and melted, these icy particles will provide enough water to sustain a colony for hundreds of years. But lunar water can also give us something else: power. Water contains the two main elements of rocket fuel: hydrogen and oxygen, and that will make the moon a future springboard for mankind's conquest of space. As a launch pad to the stars, the moon has one tremendous advantage over Earth: less gravity. Any high school student knows that gravity is the force which binds us to the surface of the Earth. And that makes gravity one of the biggest obstacles to space exploration. To escape the pull of Earth's gravity, you need enormous power, a thrust of millions of pounds per square inch, a velocity of 7 miles a second. But an escape from the moon's weaker gravity needs far less, just 1/6 the power of an Earth-launched rocket. So lunar launches will be easier and less costly. The moon will become our gateway first to other planets and then to the stars. Former Apollo astronaut Buzz Aldrin thinks the setting up of moon bases will be a key moment of the 21st century.
Around 2010, I think we'll be getting up to a point where there'll be improved exploration of the moon, and we'll have built up a settlement of 20, 30, 40 people there. And I think that around that time, there'll be some individuals who will say, I was alive and I saw that happen, and how much did that enrich my life by being able to experience those things and to see that happen. And I remember when the president committed the nation to do that.
A base on the moon will trigger all kinds of local space activity. as private enterprise gets a chance to go into orbit. Shuttle trips back and forth to the Earth would become common, but who would use them? In the epic science fiction film 2001, a distinguished scientist dozes while on his way to inspect a mysterious alien artifact discovered on the moon. In the future world portrayed in the film, short space flights are as easy as catching a plane is today. But such journeys are still the preserve of an elite few. In reality, a time may come when we all could taste the thrill of a journey into space. It's a scene which might be closer than you think. Buzz Aldrin, the first man to fly to the moon, is proposing a commercial scheme to get space tourism off the ground.
One of the requirements early in the tourism exposure is to experience the sensations of weightlessness. This is one of the reasons for going into space, to experience that new environment. And we want the tourists to be able to see what the stars look like, to see what the sunrise and sunset, 15 or 16 of these every day as we go around the Earth in 90 minutes. Then, of course, the tremendous view that you have of the curvature of the Earth, looking down and the continents going underneath you.
It looks like fun, but the aim is serious, to make money. And the money from orbital tourism could launch a whole new generation of cut-price spacecraft. Of course, space tourism is still a dream. These passengers are on a simulated flight aboard the Russian version of the space shuttle. This one is now an amusement park ride in Moscow's Gorky Park. But some businessmen believe that genuine space tourism could become a huge new industry. Among them is airline magnate Richard Branson.
For the last 2 or 3 years, we've been talking to different groups of people around the world, trying to work out which group has got the best chance of being the first to take tourists into space. And we're getting close to working out which group we want to work with and who we'll put some seed money into to try to make what would be the most incredible dream come true.
Indeed, Branson is not alone. Japanese automotive giant Kawasaki has designed a reusable 50-seat rocket, small enough to launch from existing airports. And if the Shimizu Construction Corporation has its way, space hotels like this could be in orbit by the year 2010. This orbiting giant is called the Kanko Maru. It's not even built yet, but customers are already booking rooms. And for a mere $20,000 a ticket, a view like this could be yours for the whole weekend. But near-Earth tourism would only be the beginning. As space traffic increases, so the demands for alternative forms of transport will also grow. This man thinks we can dispense with rockets and space stations altogether. Jerome Pearson is a US Air Force scientist who plans to ride into space by elevator.
As bizarre as it may seem, it is theoretically possible to build an elevator all the way into space, 22,000 miles high into geostationary orbit. Such a device would revolutionize space travel, allowing us to take thousands of tons of cargo and millions of people into orbit at a cost that is only pennies a pound compared to current costs.
Pearson first got the idea many years ago when he heard the sci-fi guru Arthur C. Clarke talk about towers into space. The elevator cable would be tethered to an asteroid in a synchronous orbit 22,000 miles above the Earth. The centrifugal force of the Earth's rotation would keep the cable aloft. From the ground, passengers would see an endless tube into space. Inside the tube, a vacuum. With no air resistance, the capsule would accelerate to enormous speeds propelled by electromagnetic rings. To take the strain, a carbon fiber cable, less than a meter thick, manufactured using a revolutionary and still theoretical process, nanotechnology. The elevator's only a stepping stone. It would give us an incredible ride into orbit, but it won't take us to the stars. To do that, we need a revolution in spacecraft propulsion. And that brings us to a fundamental force in the universe. The force that keeps the sun burning. Nuclear fusion. Fusion occurs when the nuclei of hydrogen atoms bond together at enormous temperatures. This bonding releases immense power. Enough power for the 20 trillion mile journey to our nearest star, Alpha Centauri. Rocket engineer Robert Zubrin.
With fusion reactions, we'd be able to make rockets with an exhaust velocity that would allow us to reach 10% the speed of light. With a system like that, we could reach Alpha Centauri in 40 years. Maybe not as fast as we'd like to go, but it could get us there within a human lifetime.
A fusion rocket would be 1,000 times more powerful than the best chemical rocket. This Japanese design would provide enormous thrust and long mission life. The fuel it needs is a gas called helium-3, and the nearest place we can find that is on the moon. There's enough helium-3 trapped in the surface of the moon to fuel fusion rockets for centuries. Once again, the moon becomes a fuel stop. This time for fusion-powered spacecraft.
In 200 or 300 years, we may have the energy and the propulsion needed to be able to send a crew on a 10, 20, or 30-year one-way trip to the nearest star, Alpha Centauri, to see what that's like, and still be able to bring those people back during their lifetime.
Fusion rockets might get us to our nearest star and back within a lifetime, but the trip into deep space is strictly one way. Voyages would take so long that crew members would never see Earth or their loved ones again. Space is not only vast, it is deadly, the most hostile environment imaginable. So how would travelers survive a journey that might take decades? In the film Aliens, they were put to sleep. Sci-fi calls it suspended animation. Just as animals hibernate, so the crew slept. Their heart and pulse rates were slowed, their organs and cell tissue preserved by cold. As they neared journey's end, their bodies were gradually revived. 20 years ago, when they were planning a manned mission to Mars, the Russians conducted secret experiments in suspended animation. The man in charge was Oleg Gazenko.
We experimented on lower living creatures, rats and dogs. We never dealt with human beings. There were many difficulties. Many experiments were done, but we discovered irreparable cell damage was caused by freezing and thawing the animals. So this idea remains a dream.
Science rules out suspended animation, So crew on interstellar voyages will spend decades living and traveling through space. This means they must adapt to a life without gravity. It may look relaxing, but zero gravity is in fact very harmful to the human body. The record for living in space is held by a Russian cosmonaut who spent 15 months aboard the Mir space station. Until he made his epic trip, no one knew if man could survive long periods in space. The cosmonaut's name? Valery Polyakov.
If we don't do intensive preventative physical exercises, very soon, in a week or two, we could have turned into, there is an English expression for this, miserable wrecks. The heart slows down, arteries weaken, muscles are wasted. There's a danger of complete atrophy. Salts are washed out of the bone structure. One could change in a way that it would be impossible to return to Earth.
Throughout the years of a long flight, crew members would have to exercise in a simulated gravity environment every day. The reason? When the brain senses there's no gravity, it tells the body there's no need for strong bones. The bones weaken and fragment. In effect, they begin to die.
From the moment a person enters the microgravity environment, there's an immediate response in the bone. It senses the decreased loads. It senses that the person is no longer having to walk on this planet. And at that point, the bone starts to lose its calcium. The bone loss occurs in the spine, in the pelvis, in the hips, in the legs, and seems to spare the arms and the upper body.
Without gravity, domestic life is very different from Earth. Baths and showers are out, and long hair can be a handful. But you don't go dirty in zero-G. Astronaut John Blaha.
You can give yourself a sponge bath 10 times better than you can here on the Earth, only because you're floating freely and you can clean yourself very easily. But if you take a small bead of water and just put it across your forehead, just like that, and I mean just a bead, believe it or not, that's all the water you need, and you can just wash your whole head, your whole face, your neck, and everything with that bead of water, and it will feel like you have a running faucet. And it really feels like a lot of water.
But how do you make enough air and water for the crew of a spacecraft as they travel to the stars? The head of NASA's Regenerative Life Support Program is Don Henniger.
The purpose of the life support systems we're developing now for the very long duration missions are to duplicate the functions that the Earth provides in terms of human life support. However, in a space-based system on a vehicle, we must try to duplicate all of those functions, and essentially something the size of a bus, roughly. And that's a very challenging job to try to do that in such a small volume.
Living in space needs a system which generates oxygen, absorbs carbon dioxide, and produces water. Plants do that, so Henniger plans to turn astronauts into gardeners. Plants, of course, have another use, as food. On a deep space journey, lack of storage means the crew would have to grow all the food they eat. Physical needs and comforts are one thing, but the greatest obstacle to interstellar travel may be human nature. In cramped living conditions, personal antagonism could ruin an entire mission. But what sort of person would choose to abandon their loved ones and travel to the stars? The man most closely involved in selecting Russian cosmonauts is psychologist Oleg Ryumin.
Поэтому это должны быть очень психологически сильные люди.
These people should be psychologically strong people. They must be very friendly.
Очень дружелюбны. Например,
For example, a very introvert person, a very aggressive or nervous person, cannot be a cosmonaut.
он не может быть космонавтом. Потому что
Not
находиться
everyone can bear to stay in an enclosed space with the same people for a long time, maybe for years. So, most importantly, they must love other human beings. Love, plus the ability to understand and empathize with others.
эмпатия.
This airtight chamber will never leave the ground, but it's the closest thing that NASA has to a starship. At least in creating the sense of isolation and confinement that crew members will face aboard an interstellar spacecraft. As part of an experiment in life support, 3 men and a woman were sealed inside this vessel for 60 days. They breathed recycled air, drank recycled water, and learned a lot about communal living in a confined space. One of the volunteers was Karen Mayers.
One of the things that we learned during the test is that if you're in deep space travel for a long time, you're going to need to have privacy, and what becomes your own home is your crew cabin. It's very warm and comforting to be in there, and the crew members know not to interrupt you unless, you tell them that that's all right.
Private video links to family and friends were very important to the crew during this test, but Mayers found the going emotionally tough.
Hi there, Melissa. This is Karen calling in.
Hi, Karen. How are you doing up there?
Well, we're doing pretty good today. It's been a little bit busy. I wanted to touch base and just say hi to folks. For myself, I felt that my world was inside this can. For me to change gears and to sort of step outside of the can in a video conference with friends and family was very difficult. I had to change focus from the test and from being inside, and I had to start thinking about the outside world again. And it's important to be able to disconnect just enough so that you're not longing each day for things of the outside world.
They got the little special treat. Was there any...
The total isolation and detachment of deep space travel will affect different people in different ways. In 2001, a birthday message from home means little to Frank Poole aboard Discovery 1.
Happy birthday to you. Happy birthday to you. Happy birthday, dear Frank. Happy birthday to you.
And for him, Earth seems irrelevant.
Happy birthday, Frank.
Thank you, Al. A bit flatter, please.
Nuclear fusion rockets could eventually take us to the stars, but to really open space up, we need to find a way of traveling faster than light. Until recently, scientists thought this was impossible. Now, they're not so sure. Finding a way to travel at light speed is one of the goals of NASA's new Breakthrough Propulsion Physics program, headed by Mark Millis.
The way rockets work, if I can illustrate with this balloon, is they carry propellant. And when the propellant exhausts out the back, it pushes the rocket in the other direction.
Rockets could never carry enough fuel to reach the stars. So Mark Millis and his team hope to turn science fiction into science fact.
The goal of the program, the real dream, is to find a way to propel a spacecraft without propellant. And even better than that, to see if we can go faster than light, if at all possible.
Science fiction, of course, has given us a ready means of reaching faster than light speed. It's called warp drive. In reality, Einstein's law of relativity rules it out, because it requires an infinite amount of energy. But now, a Mexican quantum physicist based in Germany says warp drive could become reality. His name is Miguel Alcubierre.
I was watching Star Trek one day, and I thought to myself, there must be a way of making a warp drive work without contradicting the laws of general relativity.
Einstein maintained nothing can travel faster than light. He argued there was a limit to the speed at which an object can move through space. But he saw no theoretical limit to the speed at which space itself could move or be moved. In other words, space might be stretched or compressed faster than the speed of light. If Alcubierre's bicycle was a spacecraft able to generate vast gravitational forces, he could alter or warp the structure of space around him.
And I came up with the idea that you can expand space behind you and contract space in front of you in an opposite way. That will actually push you away from objects that are behind you and pull you towards an object in front of you at any arbitrary large speed.
Inside a protective gravity bubble created by the spacecraft, Alcubierre would travel slower than light speed. But the warp drive would sweep the whole bubble along faster than light by shrinking and stretching the space around it. By hitching a ride with space, we could travel faster than light without breaking Einstein's law of relativity.
Locally, you wouldn't be traveling faster than light, but as seen from a distance, you would be traveling much faster than the speed of light.
Alcubierre's calculations confirm the theory is sound, but two massive obstacles remain. Firstly, to stop the bubble being crushed by the space around it, we'd need a kind of anti-gravitational force, something which is currently beyond our technology. Secondly, to trigger the warp itself, we'd have to generate a phenomenal surge of power, a greater burst of energy than the sun will produce in its entire lifetime. Small wonder that most scientists reject warp drive as a serious possibility. But this man might change all that. Dr. Hal Puthoff is the world expert on a revolutionary aspect of physics which could make warp drive a reality. He believes we will one day have the technology to tap a vast source of power that exists in the very fabric of space itself. Puthoff calls this power zero-point energy.
Zero-point energy is a form of energy that exists in empty space. Even in this room or in the far reaches of outer space, there's enough zero-point energy in the volume of this glass to, for example, evaporate all the world's oceans. One day, we'll even be able to tap this energy to travel faster than the speed of light.
Unlike any other power source, zero-point energy exists everywhere, even in the furthest reaches of space where temperatures fall to absolute zero, 273 degrees centigrade below the freezing point of water, so cold that all other forms of energy are dormant. This is cutting-edge science, which could lead to the greatest energy revolution of all. Here in his lab, Puthoff can already tap minute amounts of zero-point energy. In one experiment, ultrasound signals create tiny cavitation vacuum bubbles in water. As these bubbles collapse, Puthoff measures the zero-point energy they release. But the challenge is to harness this energy on a vastly greater scale. At present, the most potent force we have is nuclear power. In nuclear fission, the nucleus of an atom is split, releasing energy. In nuclear fusion, two different nuclei fuse together at immense temperatures. But zero-point energy is the force which keeps atoms together. If we could somehow shield an atom from it, the atom would implode, and the bang would make the atom bomb look like a firecracker. Zero-point energy is an electromagnetic radiation which has been echoing round every cubic centimeter of the universe since the dawn of cosmic time. It rains on every atom, planet, and star from every possible direction. It keeps electrons in orbit round nuclei, holds planets in orbit around their suns. In other words, it's the force which preserves the structure of the universe. An infinite, invisible sea of energy that keeps everything in its place.
When it comes to propulsion, we have the potential of a real breakthrough here. Unlike chemical rockets or nuclear rockets, if we have a zero-point energy fueled spaceship, we don't have to carry fuel. This is a fuelless propulsion system because the zero-point energy is everywhere. So we're actually tapping into the fabric of the universe. We're tapping into the generator that runs the universe. And this is available no matter where we are.
By using this limitless source of power, maybe one day we could even make warp drive possible.
I see it. It's dead on, better than any STA.
Keep flying the instruments. 12,000 feet. I heard him say nominal shoot deploy.
Roger that. Looking for 41% speed. Radar looks good.
Radar looks good here. We're coming down to 20. 210, looking good. 8, 6, 5, 4, 3, 2, 200. Touchdown.
The first crew to set foot on a planet orbiting a distant star will almost certainly face an environment like this. Spectacular, daunting, and dangerously hostile. If something goes wrong, there will be no chance of rescue, no help from Earth. The pioneers will be on their own. So how will they survive?
First thing we'll need to see to is agriculture. Probably agriculture in enclosed greenhouses because we're bringing our terrestrial plants with us and they're probably not suitable for release into the open environment. So we'll be running greenhouse agriculture and lots of it. And I think it'll be highly automated because human labor power on a colony, be it on Mars or even more so on a distant interstellar destination, will be an extreme premium.
We don't know of any planet now that has an environment that will support humans. So you live in your habitat, which has an artificial environment in it. Perhaps the oxygen is supplied by plants that you've brought with you, but still you've had to create systems to keep you alive. When you go and do work on the surface, you put on a spacesuit, but a spacesuit is really just a habitat that's shrunk to the smallest possible size that it can be that you can carry it around with you.
In time, the pioneers would build a permanent base. They would mine local minerals to make aluminium and plastics. High-tech windmills would generate electricity by wind power. In greenhouses, food and oxygen would be produced. more than 50 square meters of plants per person. But the only place that people could live without their spacesuits would be inside the pressurized atmosphere of their base. It's an enduring science fiction dream to find lush, habitable worlds in space. They might exist, but astrophysicists believe most planets are like this. Barren, frozen wastes. But by taking control of a planet's weather, scientists could create the conditions in which life would flourish. They call it terraforming. Their first target, Mars.
The terraforming of Mars is not just going to give us one planet. It's going to give us multitudes, because we're going to be learning a craft of planetary engineering. And human colonists will arrive on these planets with basically an entire set of terraforming tools and techniques, so that they will be able to take on a broad spectrum of planets and transform them into habitable ones.
Chief among the tools for planetary engineering are water, light, and heat. NASA's leading expert on the terraforming of Mars and other planets is Chris Mackay.
The first step, obviously, is heating up the planet, warming up the planet. Well, we know how to warm up planets. We're doing it here on Earth, where it's probably not a good idea, but on Mars or on another planet on another star system, we could do exactly what we're doing on Earth, which is putting into the atmosphere of this planet super greenhouse gases, gases that can be 1,000 times or even 1,000,000 times more effective than CO2 at trapping in solar energy. It's like throwing a blanket over the planet. It just traps in the heat. That would be the first step, and then what that would accomplish is essentially thawing out the planet, getting the water and getting the CO2 out from the polar caps and the regolith back into the atmosphere.
It might only take 100 years to make a planet as warm as Earth. As the ice melted, canyons would fill with water, and the landscape would become transformed. Oxygen-generating plants imported from Earth could then start to create a breathable atmosphere.
The nice thing about plants, of course, is they are self-replicating machines in some sense, and they've been optimized over millions of years of evolution to take up CO2 and release oxygen. That's their goal in life, and they've been honed by evolutionary processes to do just that.
Once begun, terraforming would take thousands of years to create a fully living biosphere. But even so, making a duplicate Earth might be quicker than hunting for ready-made worlds somewhere out there. The film Aliens offers a vision of a remote colony where planetary engineers use a vast reactor to create a breathable atmosphere. This may be the kind of environment waiting to greet the first colonists in deep space. The isolation and harsh conditions would make life tough, but if the rewards are big enough, there will always be some people willing to make the trip. Despite future technology, the first space colonists will need to be every bit as tough as the Pilgrim Fathers. But their efforts will pave the way for subsequent generations seeking a new life among the stars. The reality is that space will offer migrants infinite opportunities to go to new worlds where they can establish viable and independent communities. But will people show the same spirit as their forebears who crossed the ocean to make a new life in America?
I believe there are people that will take it on, because there are people who will sacrifice virtually anything for an opportunity to be able to go somewhere new, to create something new.
But what will persuade us to swap the comforts of Earth for the rigors of life on a remote space colony? Among the most thought-provoking writers about man's future in space is sci-fi author Bruce Sterling.
Well, if you look at the history of other colonial efforts, you can see there are a lot of motives for leaving the mother country or the mother planet. You can be thrown out for being a criminal or a layabout. You can be a religious fanatic of some kind who's going off to found a city on a hill in search of some kind of ideological purity. You can be an economic migrant simply looking for a better life. Or in some circumstances, you might actually be a scientist.
Once man moves into space, each colony would become a stepping stone to explore and colonize new parts of the galaxy. Russian academician Oleg Gazinko.
If we are to think about the very distant future of space exploration, it will probably be similar to people settling on the islands of Pacific Ocean, when gradually, throughout generations, they moved from island to island, every time adapting to new conditions and gathering energy for further exploration. But cosmic space, unlike most areas of Earth, is very hostile to humans. This is why only intellectual force, knowledge, technology will help humans explore it.
Instead of settling on alien planets, it may be easier to construct vast artificial habitats in space. Just imagine your neighborhood rolled into a cylinder and tossed into space orbit. That's the vision of NASA scientist and leading authority on space colonies, Al Globus.
Everybody who studies orbital colonies has their own favorite. Personally, I'd like a community about 10,000. It's a nice number. You can get to know a lot of them, but there's always a few people perhaps you don't know too well. I'd like a cylindrical colony, a couple miles in each direction. I might lay it out a little bit like Santa Cruz here, which is a very nice, viable community. It's got all sorts of organizations, support structures, there's a viable economy and so forth. And I'd just like to take this little piece of land, roll it up into a cylinder, and toss it into orbit. Inside, you'd want it to be a nice place to live. You'd want to have houses and trees and animals and maybe a stream, perhaps a little lake. I'd like to have a wave machine so I can still surf. There's a lot of different sorts of things you can do. In addition, because it's a controlled environment, the rain will come from sprinklers. You could have misters to produce fog if you happen to like fog. The light will probably be artificial, so the lights can be placed where you want them. They can be different colors. So you could, in principle, have something I like to call weather art. You could program your misters and your sprinklers and your lights so that they produce beautiful atmospheric effects. And one can imagine weather artists going from colony to colony, designing programs to have beautiful displays inside the colony.
In Al Globus's vision, space colonists would recreate the familiar conditions of Earth in artificial structures. But once we move into space, we will live in countless different environments, and so could evolve in countless different and unfamiliar ways. For instance, leaving Earth could change the human body as profoundly as the move our fish-like ancestors made when they quit the sea for a new life on dry land. And with cyborg technology, we could even speed the process up.
We've never actually seen what a human being might look like if it were bred, born, and raised in zero-G. You can watch people float and their legs seem like kind of useless appendages. But what if they just trimmed them off? They obviously wouldn't miss them. Perhaps they could replace them with a set of arms. It might be of more use under zero-G circumstances. There won't be any sense of, are we doing something unnatural here? Because it's all unnatural. It's unnatural from the get-go.
Isolated from one another far across the galaxy, the future inhabitants of distant planets or space habitats may have very little in common with their ancestors from Earth. The first Starship crews might take along video images of the loved ones they left behind. But such images of home would mean little to their descendants. After millennia among the stars, space dwellers may know nothing of Earth. Perhaps this is why the man who's spent more time in space than anyone alive says we must never break our ties with our homeworld. Valery Polyakov believes the essence of our humanity ultimately depends on preserving our links with the planet that gave us life.
However far man flies away from Earth, he should preserve himself as a man of Earth. Even though he goes away and lives on other planets for long periods of time, he should return home, to the grave of his ancestors, to his cradle. Earth let him go, and he must return.
But if a race of star-bred humans did return with zero-G bodies and galactic minds, could they survive in the homeland? Would they fit in? Or would they in fact have become aliens?
Discover Magazine follows in just a moment. In Money, 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 how Los Angeles, bank crime capital of the world, is keeping the robbers at bay.